Re-entry works as the process a spacecraft goes through when it returns from space and enters Earth's atmosphere. When the spacecraft is moving at orbital speed, it is traveling extremely fast, often more than 17,000 miles per hour. As it begins re-entry, the air in the atmosphere pushes against the spacecraft, creating intense friction and heat. To survive this stage, spacecraft are built with special heat shields that absorb and deflect the enormous energy created during descent. Temperatures on the surface of the shield can reach thousands of degrees Fahrenheit, hot enough to melt metal if not protected. The shield gradually burns away in a controlled manner, carrying the heat with it and keeping the inside of the craft safe. Another challenge of re-entry is slowing down safely while still staying on the correct path. If the angle is too steep, the spacecraft might burn up from too much friction, while if the angle is too shallow, it could skip off the atmosphere like a stone on water. Engineers calculate the entry trajectory carefully to balance heat, speed, and altitude so that astronauts or equipment land safely. As the spacecraft slows, it also experiences immense G-forces, pressing the astronauts firmly into their seats. After passing the hottest and most dangerous stage, parachutes or retro-rockets are deployed to slow the craft further for a safe landing on land or sea. In some modern spacecraft, wings or steering fins help control the descent and allow smoother landings. Re-entry also temporarily blocks radio communication because the heated air forms a plasma layer around the craft that interferes with signals. Once it passes through the hottest region, communication returns, and mission control can guide the final landing sequence until the spacecraft touches down safely. If you enjoyed the video, give it a thumbs up, comment, and share it with your friends. Don't forget to subscribe to our channel and hit the bell so you never miss a new video.